Welcome to chemistry lesson, NECO Practical Chemistry 2025. This is a predicted question. It may not be 100%, but I assure you that this will give you a guideline on how to go about question number 1, volumetric analysis. The question says, A is a solution containing 3.515 gram HNO3 in 500 cm cube of distilled water. Then B is a mixture of sodium triisocarbonate 4 and sodium triisonitrate 5 containing 8.00 gram per dm cube. A. Put A into the burette and titrate against 20.00 or 25.00 cm cube of B using methyl orange indicator. Tabulate your reading and calculate the average volume of the acid used. Now to answer question number A, solution to A. Now to prepare a table of your reading, you go with the endpoints that your teacher, your chemistry instructor would give to you. Now, no school will have the same endpoint, but it must be within the range of what? The theoretical endpoints. So you go or cooperate with your chemistry teacher for what? Accuracy of what? The endpoint. Don't go against the instructions of your what? Chemistry teacher when it comes to what? Volumetric analysis. So for the purpose of this video, we'll be using the endpoint 25.80 cm3. To prepare our table from this 25.80 cm3, we could have volume of pipettes used, and the volume of pipettes we are using in our school is 25.00 cm3. Then indicator, as stated in the question, indicator used is methyl orange. Yes, to avoid mutilation, to avoid cancelling, you could always what? Enter the letters before drawing your line. From here, I could write burette reading. Burette reading must be in cm cube. Then from here, you engage your meter rule and put up the line. Here is final reading. And here is initial reading. And here is volume of acid used. NECO would always prepare a table starting from rough, then first titration, second titration, and finally third titration. I could give you a table like this. You know your endpoints to enter in your values. The initial reading always will refill to 0.00. And in our first titration, because the apparatus are not adapted to the titration, we could have a rough reading of 26.50. And 26.50 minus 0.00 will still give us 26.50. Then we refill to 0.00 again, and we have 25.80. And 5.80 minus 0.00 will still give us 25.80. Because we are consistent, when we repeat to 0.00, we titrated again and still get 25.80. Bring down 25.80. Then our third titration, when we repeat to 0.00, we had 25.60 and 25.60, which means that our average volume of acid used will be equal to the tray concordant or consistent reading, because the difference between 20 first titration, second titration, and third titration is within 0.1 to 0.2. So we could have that 25.80 plus 25.80 plus 5.60, all divided by 3. And when we did, student, punch your calculator. Engage your calculator. 25.80 plus 25.80 plus 25.60 divided by 3.
25.73.
You have 25.83. Make sure the unit is in what? cm cube. This becomes our what? Average volume of acid used. Then you could use this value generated. From here, you already have what is called CT, complete what? 0.73.
Yes, sir.
25.73.
Not 8.
Okay. Here. 25.73. Okay. Now, if you prepare your table like this, which means you already have complete what? Table CT from the marking guide, which will give you 5 marks. Now from here, because all the values or the numbers you entered inside the table is approximated to what? 2 decimal places. You have your what? DP, decimal placing, as also 5 marks. Now your ability to select 2 or more what? Consistent what? Tighter values or consistent what? Readings. We give you your principle of what? Averaging. Because we selected the what? The best 3 that are what? Concordant or consistent. And you get your average volume of the acid used. That will give you what? 5 marks. The accuracy of titration, AC. We know that the endpoint is within the what? The accurate range, and that will also give us what? 5 marks. Now the application of these values in solving problem. Question number 1 is it? From your what? That's B. From your results and information provided, calculate a concentration of A in mole per dm³. Concentration of A in mole per dm³. And this question BI. Concentration of A in mole per dm³. If you go back to the question, you discover that the concentration of A is given in gram as 3.5, and the volume is given as what? 500 cm³, which means that the ideal formula that I could solve this will be conc. That's the short form of concentration in mole per dm³ of A will now be equal to mass of A all over molar mass of A. Multiply by 1000 cm³ of solution A all over volume of what? Solution A. Which means that conc in mole per dm³, conc in mole per dm³ of A will be equal to, from the equation, mass of A is given as what? As 3.15. Then the molar mass of A